Hello everybody, welcome back to the channel. Hope you like my previous video, Matter in Our Surroundings. In this video, I'll share some important points from the chapter Motion. Motion. We often perceive an object to be in motion when its position changes with time. Describing motion. To describe the position of an object, we need to specify a reference point called the origin. Motion along a straight line. The simplest type of motion is the motion along the straight line. A physical quantity can either be a scalar quantity or a vector quantity. A physical quantity which has only magnitude is known as scalar quantity. Example, time and speed. A physical quantity which has both magnitude and direction is known as vector quantity. Example, velocity and force. Distance. The distance covered by a moving object is the actual length of the path followed by the object. It is scalar quantity. SI unit of distance is meter. Displacement. The shortest distance measured from the initial to the final position of an object is known as the displacement. Displacement is a vector quantity. It can be zero when initial point and final point of motion are same. SI unit of distance is meter. Two different physical quantities, the distance and the displacement, are used to describe the overall motion of an object and to locate its final position with reference to its initial position at a given time. There are two types of motion, uniform motion and non-uniform motion. When an object covers equal distance in an equal intervals of time, it is said to be in uniform motion. When an object covers unequal distances in equal intervals of time, it is said to be non-uniform motion. Speed. Speed is the distance traveled by the object in unit time. The SI unit of speed is meter per second. In most cases, objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance traveled by total time taken. Speed with direction. Velocity. It is defined as the distance covered by a moving object in a particular direction in unit time or speed in a particular direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate average speed. In case the velocity of the object is changing at a uniform rate, then the average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. Speed and velocity have the same units, that is meter per second. Rate of change of velocity. In non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. Acceleration is a measure of the change in the velocity of an object per unit time. That is, acceleration equals change in velocity by time taken. The acceleration is taken to be positive if it is in the direction of velocity and negative if it is opposite to the direction of velocity. The SI unit of acceleration is meter per second square. Graphical representation of motion. Graphs provide a convenient method to present basic information about a variety of events. A straight line graph helps in solving a linear equation having two variables. To describe the motion of an object, we can use line graphs. Distance time graph. The change in the position of an object with time can be represented on the distance time graph, adopting a convenient scale of choice. In this graph, time is taken along the x-axis and distance is taken along the y-axis. When an object travels equal distances in equal intervals of time, it moves with uniform speed. This shows that the distance traveled by the object is directly proportional to the time taken. Thus, for uniform speed, a graph of distance traveled against time is a straight line. We can use the distance time graph to determine the speed of an object. This is the distance-time graph of an object moving with uniform speed. And here is the distance-time graph of an object moving with non-uniform speed. Velocity time graph. The variation in velocity with time for an object moving in a straight line can be represented by a velocity time graph. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time graph will not change with time. It will be a straight line parallel to the x-axis. We can also study about uniformly accelerated motion by plotting its velocity time graph. For all uniformly accelerated motion, the velocity time graph is a straight line. This is the velocity time graph for uniform motion of an object. And this is an image of velocity time graph for an object moving with uniform accelerations. Equations of motion by graphical method. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by it in a certain time interval by a set of equations known as the equations of motions. A set of three such equations are v equals u plus at, s equals ut plus half at square, 2as equals to v square minus u square, where u is the initial velocity of the object which moves with uniform acceleration a for time t, v is the final velocity, and s is the distance traveled by the object in time t. If an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Hope you guys liked the video. Please like, share and subscribe. See you in the next video. Bye!